Hey y'all, in this lesson, we are taking a look at adding, subtracting, multiplying, and dividing real numbers. By the end, we want to be able to add, subtract, multiply, and divide real numbers. Our essential question for this first lesson is, what are the rules for real number operations? Let's get started. So some new vocabulary we're going to see is things like additive inverse, multiplicative inverse, identity, absolute value, things being undefined. Our first rules are for addition. As you're filling in your notes, you are going to fill in the missing pieces. So addition, numbers with the same sign, you are going to fill in, add the numbers, and use the same sign. Next to numbers with the different signs, you will fill in, subtract the numbers, and use the sign on the bigger number. For subtraction, we are simply going to add the opposite. And for multiplication and division, we have our sign rules, which are the same for either one, and that is that numbers with the same sign, we're going to write that we multiply or divide as normal, and the answer is positive. And with different signs, we multiply and divide as usual, and the answer is negative. Here's an example of adding two numbers with the same sign, whether it's positive or negative. Here's an example of adding two numbers with negative signs, one where the answer ends up positive and one where the answer ends up negative. Here is an example of taking a subtraction problem and changing it to an addition problem. This one ends up being addition with different signs. And here are some examples of multiplying with the same or different sign and dividing with the same or different sign. Let's look at some examples. 5 plus 3, we have the same sign, so we're going to add the 5 and 3. These numbers are positive, so positive 8 is our answer. For negative 4 plus 3, we have opposite signs, so we're going to find the difference. The difference between 4 and 3 is 1. And then the larger number, 4, is negative, so our answer is negative. When we subtract, we're going to take 5 minus 9 and change it to 5 plus negative 9. We're adding numbers with opposite signs, so 5, the difference between 5 and 9 is 4, and 9 being the larger number with a negative, we have to have a negative on our answer. Negative 8 minus 2 changes to negative 8 plus negative 2. Now it's an addition problem with the same sign. So we're going to add the number portion. 8 plus 2 is 10, and they're both negative, so our answer is negative. When we multiply 3 times 8, those have the same sign, so my answer is positive, and 3 times 8 is 24. 2 times negative 8, those have different signs, so my answer is negative, and 2 times 8 is 16. Similarly, when we divide, 20 and negative 2 have opposite signs, so my answer is negative, and 20 divided by 2 is 10. Negative 45 divided by negative 15, those numbers have the same sign, and 45 divided by 15 is 3. You try the examples on your page under the You Try section. Pause the video, do these problems, and then play the video when you're ready to see the answers. Here are the answers for the You Try problems for you to check and make sure you are good to go. Feel free to pause the video and then continue on when you are ready. So the next part, we're going to be filling in some blanks. I have underlined the words that you do need to fill in. So let's get started. A number and its opposite are called additive inverses. In order to subtract, you are actually using the additive inverse because subtracting a number is the same as adding the opposite, which is what an additive inverse is. Going to the top of the second page of notes, two numbers are reciprocals if their product is 1. So we multiply and they get 1. Like if I take 5 and multiply by 1/5, my answer is 1. So they are reciprocals. A number and its reciprocal are called multiplicative inverses. Now, one thing I want to show you with reciprocals is that this 5 is really 5 over 1. So when I'm looking at its reciprocal being 1 over 5, this is where you see that people normally say that reciprocals are basically just flipping your fraction. You're just taking it and flipping it over. That will get you a reciprocal. To divide by a number, you can multiply by its multiplicative inverse. This is helpful especially when dividing fractions. So by dividing a non-zero number, it's the same as multiplying the reciprocal of the number. And we'll see this when we look at our example problems that have us dividing fractions. Lastly, we have some rules around 0. The product of any number and 0 is 0. The quotient of 0 and any non-zero number is 0. However, division by 0 is undefined. So here are a couple examples. Additive inverse, showing that subtracting 6 is the same as adding -6. And multiplicative inverses, showing that dividing by 5 is the same as multiplying by 1/5. You end up getting the same answer of 2. Here is those 0 rules again. Multiplying by 0, the product of 0 and any number is 0. So that's like 5 times 0. 0 divided by any number. So that's the quotient of 0 and any number. You might also see it written as 0 over 4, like a fraction. Finally, there we go. Dividing by 0, this cannot be done. This is what we could say is undefined. So again, you could see this as a fraction of like 9 over 0. And that's not possible. All right, let's look at some examples. Additive inverses. When you think of additive inverses, what do we add to get 0? It's the opposite of what we have. So the opposite of 5 is -5. The opposite of -3 is +3. When we think of the reciprocal, we're thinking of what is that number as a fraction flipped over. So 4, it's really 4 over 1. So when I flip that over, I get 1/4. 3/4, flip that over, I get 4/3 or 4 over 3. When I go to add fractions, 1/2 plus 3/5, I need to have like denominators. 2 and 5 are not the same denominator, so I need to get like denominators by finding the least common multiple. I'll do that by listing out the multiples of 2 and 5. So the multiples of 2 are 2, 4, 6, 8, so on and so forth. And the multiples of 5 are 5, 10, 15, 20, and so on. The smallest number that they have in common is 10. So I'll set up my addition problem as 2 fractions over 10 being added together. Now I need to determine what my numerator is by looking at multiplication. 2 times what number gets me 10? Well, it's 2 times 5. So I'll do 1 times 5, which is 5, to get my numerator. For 3/5, 5 times what gets me to 10? Well, 5 times 2 gets me to 10. So 3 times 2, 6, gets me the numerator for my fraction. 5 plus 6 is 11. 11/10 is my answer. For part B, we're going to rewrite that 4 over 1 to have it as a fraction. Then the least common multiple is 2, so 7/2 will stay the same, but 4 over 1 will change to 8 over 2. Add them together and we get 15/2. Dividing. When we divide, remember we're going to multiply by the reciprocal. So 3 divided by 1/3 changes to 3 times. 1/3 flips over to be 3 over 1, which is really just 3 times 3, which is 9. And finally, B, we have 3 over 2 divided by 5/8. 3 over 2 stays the same. We're going to multiply now by 8 over 5. 3 times 8 is 24, and 2 times 5 is 10. We can reduce that fraction by dividing both top and bottom by 2, and we get 12 over 5. To fill in our summary for this, fill in those underlined words into your summary. For addition with the same sign, we're going to add and keep the sign. For a different sign, we'll subtract and use the sign from the bigger number. For subtraction, we'll add the opposite, which is the additive inverse. For multiplication, if they have the same sign, it's positive. If they have different signs, it's negative. For division, the sign rules are the same as multiplication. To divide, you can multiply the reciprocal, which is the multiplicative inverse. This completes the first lesson of Unit 2. You need to complete the 8 practice problems on the page following your notes before you then take your mastery check and continue on to the next lesson. Good luck, and I'll see you in the next lesson.